I'm Eric Magnus. I'm an engineer with Sysdig. I won't talk too much about Sysdig. Actually, I won't tell you anything about Sysdig. Just that we are a cool software company and we make a cloud-native tool that helps people monitor and secure their Kubernetes and just general container environment. So, like, afterwards we can talk a bit if you guys got any questions about that. But I mean, today I think let's talk about another kind of monitoring, which is it's pretty cool, and it's Prometheus. And you see, I got a real highfalutin sounding title right there. And so, who here has played around with Kubernetes? That's pretty good. Who here has rolled it out in like production? Damn. Austin. There we are. So, you know, maybe you know, rolled it with Kops, you know, could have been GKE, could have been doing it in Docker EE if you want, could be Rancher. I love Rancher. Rancher's awesome. Or, you know, you could have gone like crazy and done it, you know, in OpenShift. How's that for a back end there? But, you know, no matter how you did it, you know, what are you going to do on day two? So once you actually start, you know, putting some apps in there, once you start running workloads in there, how are you going to stay on top of just that infrastructure? Because there's a lot of infrastructure. I mean, look at all that. There's a lot of infrastructure. But how are you going to stay on top of that? How are you going to be alerted when something goes wrong? And I mean, those of you who have, you know, deployed Kubernetes, have you noticed things do go wrong from time to time? Yeah, it's not there yet. You need to be able to be alerted. Also, you know, Kubernetes is all about applications. It's all about letting developers very quickly roll out applications and make them fully redundant and accessible and all that. You need to monitor those applications, and even better, give developers access to monitor those applications themselves. And so you need, for day two, you know, I got your big present on day one, but you need a monitoring platform, which is just as important, I think. So Prometheus is a fantastic way to monitor things. And so I'm just going to give you the quickie. I'm sure if everyone's rolled out Kubernetes here, you're probably familiar with this, but so, you know, Prometheus, you know, was developed at SoundCloud internally, and like SoundCloud, I guess it's that website where your friend's band, they upload their music. You guys have one of those? Yeah. Anyway, it was their own internal monitoring system. And actually, I believe they modeled it after BorgMon. So just like, you know, Kubernetes was, you know, modeled after Borg, they modeled this after Google's own monitoring platform. They contributed to the CNCF in 2016, and it, you know, was officially graduated just 2 years after, which is actually pretty amazing. So, you know, very successful open source project. And it's kind of funny. So Prometheus means a lot of things to a lot of people, and it's got some key. If you ask me, this is what it mainly is. So first of all, it is definitely at its core. There's a time series database. It's that monitoring server. But it's also an entire stack. You know, there's a lot of components that go into a monitoring platform. There's the alerting module. There's that time series database. There's some kind of front end. So it's that as well. It's the interface. It's the API to pull those metrics. And then finally, and I think this is most important really, it's a way to actually instrument your code. So I'll kind of talk about this stuff. First off, I think, like I said, I think this is most important. We'll start with instrumenting code. So, you know, in the old days, like, you know, 2 years ago, monitoring vendors like Sysdig and others, you know, we had to provide custom and be able to ingest custom metrics that were really application and language specific. So, like, you know, JMX, you know, good old Sun/Oracle/ you know, whatever. StatsD, XPVARs, you know, it's like your Go metrics out. And all of these, again, were very vendor specific. They're kind of like the opposite of open. And it was a pain in the ass for everyone. That's really no surprise. So you're like, developers, you have to maintain this huge application-specific code base that can't be ported across your environment. So it really doesn't, I mean, it has value to you because it's important, but it's very hard quantifying that value to, say, management. So again, it's really tough to get these off the ground. Every vendor is going to have their own interface. A lot of times, those specific metrics, things are not even available for whatever language you're developing in. And this is kind of why we're all here. They don't always work with microservices, which is a huge problem in 2019. So Prometheus, I think that's why Prometheus was so successful so quickly, because it really became this industry standard for exposing metrics from any application, essentially. And out of the box, it supports a cloud-native infrastructure. So it supports cube state metrics. It supports the entire Kubernetes control plane. It also supports, out of the box, really key cloud-native apps like Istio, like Traffic, again, Rook. These are, again, really key when you're trying to roll out a modern metrics platform. And then, of course, because it is open, because it's one shared code set, you just need to instrument your code once, and that can be extended across everything there. And so, I think one reason why Prometheus became successful along with that is so when you think of metrics, here's old style metrics, and these would be, again, in like StatsD, for instance. This is what a StatsD metrics looks like, and you can see they're a dot notated format. They're a hierarchical. Is that pronounced? However you pronounce it, but they're that format, and each part of your actual metric builds off of the previous part of the metric, and so you really have to handcraft each one of these metrics. And they're not applicable to your entire infrastructure. Again, they're specific for one specific thing, and making changes to that can get really difficult. Prometheus, and this, to me, this has always been a really critical part about Prometheus. It takes a tagged format, and that sounds familiar. That's kind of how Kubernetes works. You come up with a specific metric, and then you start adding labels to it. And you can do really powerful things like that. So you can just take one core metric, real basic metric, HTTP requests per second, but start adding labels to it, and you could really quickly say, how many 404s are we getting, in production in my, East Coast data center? And that's just one specific metric. And so being able to really quickly create these portable compound metrics is incredibly useful. And so, to that end, Prometheus has just 4 core metric types. So there's a counter, just like it sounds. It just increases over time. There's also a gauge, and so that can go up and down. Counters can only go up. There's histograms, and histograms are actually probably the most common form of metric. So a histogram is going to be something like response sizes, stuff like that. And finally, summaries. And so a summary is like a histogram, but it actually calculates the quantiles over a time window. So this is how you get like 95th percentile. And these are really useful, A, because you want to see what your system is like under load. So you want to see your worst case scenario. And B, computing those at the front end is a lot easier than computing it at the back end. So if you can export that just as a straight metric without having to process anything on the back end, really useful. I'm not going to read this, but it's good. It's really good stuff. So Prometheus comes, again, out of the box with official libraries for Go, of course, Python, Ruby, Java, And then there are unofficial libraries for pretty much everything. I mean, I'm sure there's a few languages that aren't on there, but again, just about everything people are using in a modern environment. And so, along with the actual way to instrument your code, remember, Prometheus is an entire monitoring stack as well. It's not just a way to instrument code. And so, the monitoring stack for Prometheus, it's got a few moving parts. It has the actual Prometheus server, and that's that time series database that's taking in those metrics. It has the alert manager, which is just what he sounds like. Grafana, so I'm sure everyone here is using Grafana for all kinds of things. It's the most popular way to visualize your Prometheus data. There's other ways too. It has Prometheus exporters as well. So that's what is actually scraping those metrics and emitting those metrics that are then imported by the Prometheus server. And finally, there's what we call a push gateway, which is not really recommended, but for specific types of metric, a push gateway will actually push them. Normally, it's a pull series, but for things like batch jobs, very, very, very quick batch jobs that just emit a metric and then shut down, that's where you need to use a push gateway. But normally, it's just a pulling system. So you can see here, you got the Prometheus server kind of living in the middle there. And you got the alert manager. He's going to be talking to PagerDuty or to Slack or whatever. PromQL is the query language. So that's querying the Prometheus API there. And that's sending your data to Grafana or whatever UI that you have. And you also have the service discovery. So that's going to say discover things like that cube state data. So Prometheus, I think part of the beauty of it is how nice and open it is. Part of the problem with it, and it does have problems, everything's got problems, is that it is fully a DIY thing. So no two stacks are going to be the same. And so things can change. There are a lot of things to babysit. And the user, really, he's going to care about that and that, or she is going to care about those two things. So for visualization, like I said, Grafana is pretty much the de facto standard right now, but the nice thing is you don't have to use Grafana. So for instance, at Sysdig, we automatically import Prometheus metrics. If we see an exporter, we will just start scraping that data, and you can visualize Prometheus data in our UI, which gives you a lot of other cool things you can do. So you don't have to use Grafana, and a lot of teams sometimes don't want to change. So we support that. Everyone supports that. So Grafana, I don't think I need to go too much into that, but Grafana's an awesome platform. It's open source, and it lets you visualize pretty much anything. It's fairly simple to put together a dashboard. It takes some babysitting, but it's fairly straightforward. So exporters are how data gets from those applications, or from even there's a node exporter. That's how you get things like CPU and disk and everything. So exporters are going to expose metrics, and it just exposes it via HTTP. Remember, it's a pull. So if you see a metric being emitted, Prometheus will start importing that. There are just a ton of different exporters. So it's very, very simple to roll out a new exporter in your environment. Generally, it's just a case of seeing that and starting to pull the data. So collecting other things that can emit metrics. So for instance, the cube state, that's not going off of an official exporter. They're being emitted by Kubernetes. Also, Sysdig, so we have the Sysdig open source agent. Has anyone played with Sysdig at all? Cool. So, good job. So, we also have our commercial agent, which generates all kinds of really cool data. It's generating that data at the kernel level. So, again, different ways to gather that data. Talk about the metrics server. And this, if you ask me, The metrics server, I mean, I may be biased, I work for a monitoring company, but the metrics server with Prometheus, I think, is the weakest link with it, really for these challenges. And the reason why, kind of the core of it, so it's that time series database, and it does not guarantee durability. It's a pretty fragile database. And so there are other alternate backends you could use, like Cortex, where you can actually give it some sort of durability. But really, out of the box, it's a kind of janky way to. It's not meant for long-term storage. Basically, that it's good for real-time metrics. But again, if you want to say, how did things look 2 weeks ago? Not the best way to do it, unless you start deploying something else. So, like I said, complexity, scaling. Again, the back-end infrastructure for Prometheus was never really meant to extend where it does. And then finally, because you don't have that historical data, you can't really get that level of insight with it. Otherwise, I mean, that's as if that's the only problem, that's not really that bad. And so, lots of vendors offer a hosted Prometheus backend, which actually kind of solves that time series database issue. You know, if someone else is dealing with it and has made the various architectural changes to make that happen, that's great. So there's Weave Cloud, Grafana Cloud. Also, Sysdig, just use an entirely different backend. That's actually a really popular thing. So you just have developers instrument apps, instrument the code via normal Prometheus exporters, and just let Sysdig take in all of that data, and you can visualize it and do a lot of really cool stuff with it. So again, lots of ways you can get around that database issue and give it some long-term durability. That's it.